Okay, so now we are going to start talking about measurements and density. First off, what is a measurement? A measurement is a way of expressing an observation with greater precision. It provides a numerical value for some of the property of the object or the events being observed. All measurements consist of two things. The first thing is the numerical value. And the second thing, very, very important, is the unit, the label. Give it something to it, like grams, centimeter, milliliters, grams per milliliters, and all of that. It could even be like how many desks you have. It has a unit to it. Properties that can be measured include length, area, volume, mass, weight, temperature, density, time, and more. And then we have a thing called linear measurement or a dimensional measurement. This is just the distance between 2 points, and we are going to see this in a couple places. It's not necessarily going to be called linear measurement. It might just ask for the distance between 2 places or 2 points. All right, so what instrument would we use if we were going to measure that? So to measure that, typically we use a ruler or a meter stick. Why meter? Because it's the basic units in science. All right, so the basic unit is a meter, and we can go to the tenths or more, the tens powers, and we can call them different things. So for instance, if you see centi in front of a meter, it means it's 1/100th of a meter. So 1 centimeter or 1 meter is 100 centimeters, whereas milli or milliliter is 1,000 milliliters to a liter, or a meter, sorry, meter. And then you've got kilo. Well, there's 1,000 meters and 1 kilometer. Along with measurements, besides having length or dimensional, we're going to do volume. There's a couple ways you can measure volume. A three-dimensional measurement of volume or liquids, you are going to use this thing right here. Hopefully you remember it's a graduated cylinder. These graduated cylinders use the units of milliliters right there. And this measurement, if you look right here, is 67 milliliters. Well, how exactly do you know? When you look at this section, you want to be eye level with it, straight eye level with it. And you'll notice where the bottom of the curve or the meniscus, you're going to look for the bottom of it. And the bottom of it is right here. And you go 1, 2, 3, 4, 5, 6, and 7. That is 67 milliliters. All right, based off that, I would like you to pause real quick and tell me the different milliliters below. All right, let's see if you got it right. You got 7 milliliters, 38 milliliters, 33 milliliters, and 20 milliliters. Okay, so the first one we were saying is a three-dimensional if you're dealing with liquids. Now say you're dealing with a regular sized solid, a box, even Post-its, like a thing of Post-its. You can measure the volume or how much space it takes up with, again, a ruler. The formula for this is length times width times height. In this, we use cubic units because you're timesing centimeter times centimeter times centimeter. So you're going to get either cc's or meters cubed. In this case, it'll be centimeters cubed because we want to go small. And there's your centimeters cubed. All right, so how many cubic centimeters are in 1 milliliter? Well, this is a 1-to-1 ratio. Basically, however many centimeters cubed you will have milliliters. They're interchangeable. You can switch out those units. Ideally, though, you want to stick with whatever you measured it with. All right, so let's see if we can determine these. Get a calculator if you need. So 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 is 27 centimeters cubed. All right, let's look at this. We've got 6 times 8 times 3. Let's see, that's 24. 24 times 6 is 80, oh, no, sorry, I was off by quite a bit. 144 centimeters cubed. Can't do that one right off the top of my head. This next one isn't too bad. So 4 times 4 times 10. So 4 times 10 is 40. 40 times 4 is 160 centimeters cubed. All right. Let's look at this. So we were looking at the regular. Now if we have like an irregular shaped. So say I want to get the measurement of this right here. You're not going to be able to measure length times width times height. So what are we going to do? We're going to take that graduated cylinder and we're going to fill it with a known volume. So say I fill it with 50 milliliters, right? I'm going to carefully take my little metal ball and I'm going to drop it carefully to the side so it doesn't splash. You don't want any of the water to come out. Drop it down in. And when I drop it down in, the water level goes up to 60 milliliters. Okay, so how do I get the volume? The volume is how much water displaced it. So it went from 50 to 60. Just subtract the two. It is 10 milliliters. It has a volume of 10 milliliters. And again, if you're using water, stick with milliliters. All right, mass. How do we measure mass? Mass, well, what is it? That is the amount of matter any object has. How do we measure it? Well, first up, we have these, these balances. This one is a digital balance. This one is a triple beam balance. And we'll look at those in just a second. Our units for them are typically grams or kilograms. It depends on how far. This one usually goes grams. This one is kilograms. It's how specific it is, how precise it can get, or accurate, sorry. And let's look and see if we can figure out the mass of these on the triple beam. To start with that, I always go with the largest and work my way down. So like this, pause if you need to figure it out. You go 142. Let's do it again. Stick with the top one. 244. 120. And these are all grams, by the way. There's 0 here. So it's 43 grams. Okay? The big part of this is we're getting to density. Density is going to show up a couple times. It usually shows up at least once on the regions, at least, if not more. So you want to know the density formula. All right, what is density? Well, it's the ratio of the amount of weight or mass per unit of volume as a measure of compactness of a substance. So what is density? It's how compact something is. How much space and how much mass is there all together. It's a ratio. Ratios are just a fraction, something over something. So in this case, density, if you look at the front of your reference table, it will say density equals mass over volume. So one way that I remember it is I have my density triangle. So if I have my density triangle and I need to figure out density, I'll cover up the D on this and I see it's mass over volume. Pretty easy, right? So what if I say, hey, I want volume, but I have density and mass. So cover up the volume, it's mass over density. Cool. Well, what if I want mass? I have density and volume. How do I find out the mass? Cover the M and it's density times volume. Because in math, anything right next to each other, like an X times a Y is XY. You times them together. All right. What's so important about density? Well, density moves everything in this world. Everything. Water. How does it move water? Well, warm, less dense water floats to the top, where cold, more dense, floats to the bottom. And this happens all around the world, not just in one spot, but if you have the equator's down here, and then you have the poles, the warm will start to go up towards the cold, which is the poles, and the poles will sink down towards the equator, and it kind of makes this gyrating circle gyre. We'll learn about that later. And that moves water. And then air, same with the air. The warmer the air, the higher it goes. The colder it is, it sinks back down, and it makes a nice little circle, which causes air pressure to move, which causes storms to move, and the jet stream. And then you even have magma underneath us. Warm, again, floats up. It's less dense. It floats up towards the surface, whereas the cold sinks down towards the bottom. And this moves the plate. So density moves everything. It's very, very important. And one of the reasons why we got to learn how to measure it. All right, so that is it for our notes today. If you have any questions, don't hesitate to ask. And I hope you guys have a great day.